That puts the unhybridized p orbital above and below this plane. In this video, we're going to look at the geometry of various hybridized atoms. I just finished a video where we derived the hybrid orbitals. I'll put a link to that below. If you haven't watched that video, you should go ahead and watch it first. It's got a nice analogy with rum and coke that you don't want to miss. But in this video, we're going to look at the shapes of those atoms. The key thing to keep in mind as we go through these shapes is that we want to keep the electron domains as far apart from each other as possible. Electrons don't like to be occupying the same space, so when we draw the shapes of these hybrid orbitals, we want to keep the electron domains as far apart as possible. In sp3 hybridization, we have 4 sp3 hybridized orbitals. To get those orbitals as far apart from each other as possible, we're going to point them towards the corners of a tetrahedron in 3-dimensional space. We'll have our carbon atom. We can have one orbital pointed up to the left, one orbital pointed down to the right. And if I kind of put these in a plane, where this plane is implied to be perpendicular to the screen, where all the carbon atom and these two orbitals are all in that plane perpendicular to the screen. The way we get those orbitals as far apart from each other as possible is then we have one orbital sticking up above this plane, and one orbital sticking down below this plane. This would be an sp3 hybridized atom. This would look something like this in 3 dimensions, where we have our two orbitals in the plane, one sticking above and one sticking below. This is the tetrahedral geometry for an sp3 hybridized atom. This is how we can get those orbitals to be as far apart from each other as possible. These orbitals now have electrons, and they can use to form bonds with other atoms. In sp2 hybridization, we have 3 sp2 orbitals and 1 unhybridized p orbital. These orbitals have different shapes. So in order to get them as far apart from each other as possible, we'll start with our carbon atom. We're going to put the 3 sp2 hybridized atoms in the same plane, trigonal planar geometry. Again, if I kind of draw my plane for this picture, again, this plane is coming in and out of the board. All 3 of these orbitals in the carbon atom are all on the same plane. That puts the unhybridized p orbital above and below this plane of the trigonal planar geometry. The 3 sp2 hybridized orbitals are all in a trigonal plane, and the p orbital is perpendicular to that plane in this geometry. That would look something a bit like this. Again, the different shading on the different lobes represent the different signs of the orbitals. We have the 3 sp2 hybridized orbitals all on the same plane, and the p orbital perpendicular to that plane. For an sp hybridized atom, we have 2 sp hybridized orbitals and 2 unhybridized p orbitals. To get these as far apart from each other as possible, we'll start with our carbon atom. The sp hybridized orbitals will be pointed 180 degrees opposed from each other in a linear geometry. We draw in our plane here. To do the other 2 p orbitals, we need to think about it in terms of x, y, z coordinates. If the 2 sp orbitals are on the x-axis, the 1 p orbital we can think of it on the z-axis, sticking above and below that plane. The other p orbital will be like on the y-axis. It'll be sticking towards you on the y-axis and away from you on the y-axis. So the 2 sp orbitals are 180 degrees opposed to each other on the x-axis. The 1 p orbital is on the z-axis, and the other p orbital is on the y-axis. This is how we can get these orbitals as far apart from each other as possible. This is a picture of what the sp hybridization would look like. Again, we've got our 2 sp orbitals in the horizontal plane, 1 p orbital up and down, and 1 p orbital towards and away from you. This is how we can draw the pictures for the hybrid orbitals in organic chemistry.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.